In this area, in this video, we're going to take a look at a very important concept, a very important basic fundamental mathematical concept of ratios. So we're going to look at what is a ratio and how do we use them. So we're going to start by looking at a very common everyday example that most of us will understand. You've all been at a summer camp before at some stage. It may have been for football, may have been for gymnastics, athletics, even just a fun camp, whatever it was. You've all been at one before. And we understand that the rules at youth camps or summer camps tell us that there must be a ratio of an amount of adults for every certain amount of children. So a typical ratio might look something like this. You have to have one adult for every 6 children. And we write that like this. 1, we've got these 2 dots, and then 6 like this. What this means is you have to have 1 leader for every 6 children at the camp. Now, most of us can figure out that, okay, well, if I had maybe 12 children, I would need 2 leaders. Now, essentially what we've done here is we said, okay, well, if we're going to have 12 children, what we've done here is we've multiplied the number of children by 2. We have to take the leaders and we have to also multiply those by 2. So we also have twice the amount of leaders. So that would be 2 leaders for 12 children. So essentially taken our ratio and we've rewritten it for twice the number of children. Now that's quite easy there. And I just want to show you how it links to something else that we've learned. It links to like something else that we've learned where we did unit analysis. This is essentially the same thing as saying that for every 1 leader, there should be 6 children. Okay, so essentially where we learned a ratio is essentially a fraction. It's the same thing, 1 leader for 6 children or 6 children per every 1 leader. So you see here the link between ratios and fractions. So I just wanted to make that clear to you. So a lot of times you can do sums or problems, you can work them out in 2 ways. You can use the ratio method like what I'm going to show you today, or you can use unit analysis and work that way using the unit analysis, canceling stuff out. That's just an aside. If you don't know what I'm on about, I suggest you go watch the video I did on unit analysis. Back to ratios for a second. This one is a very easy example, was we just doubled the amount of children. But it may not always be that easy. It can get a bit more complicated where we are using different numbers. So say, for example, the rule is the ratio is 1 adult for 6 children, same as before. And that's pretty standard summer camp rule. Sometimes it might be 8 children per 1 leader. Sometimes it might even be up to 10 children per 1 leader. School trips is the same. When teachers go away, generally there's a rule that there can't be more than 10 students for every 1 teacher. So these ratios exist to make sure that there's enough adults to protect all the children, keep them safe. But what if you were asked, say, for example, how many leaders would you need for 100 children? It's not so easy then, okay? It's very easy to see that 12 was double of 6. So you double the children, you double the leaders. But it's not so easy to see when you have 100. So I'm going to talk you through the process of how we would do this, okay? Now, obviously, we know which side is the children and which side is the adults. So good idea to write that down here. Maybe you might write it over it like this. So leaders to children. So that's the first step you will always need to do, is write down your ratio, what you know. So maybe we'll write this in a set of steps that we can follow when we want to use ratios to solve problems. So step 1 will always be to write down the ratio. Write down the ratio, like I've done here, 6 to 1. So 6 children for every 1 leader. That's the first thing. If you want to write these set of steps out, that'd be a good idea, but I would suggest do it at the end. Watch the full example, then pause, then go back and write down the steps if you want to. If you're trying to write and listen at the same time, you've not got the working memory to be able to do those 2 things at the same time. It's better to listen and watch and understand, and then go back and take it down if you need to. All right. So what would the second step be? Well, the second step is, well, we need to convert from 6 children to 100 children. I call this writing down the target. The target is we want to convert this or change this to 100 children. So I'm going to write down the target, and I'm going to write it on the children's side. So I'm going to make sure it's on the right because the children are on the right. So the target is to convert to 100 children. Okay, so that will be step 2, I suppose, will be write the target, like I've done there. Step 2 would be to write the target. That's what I just did when I wrote down 100. Okay, so I suppose the step 3 then is you want to convert to Apologies about that. I just got a little interruption here, so I had to pause the video. So we're back now. Yeah, so step 3 then, I suppose the first thing that we want to do is we want to take our original number of children and divide by that number. So divide by the first number, if you like. The reason we want to do this is we always want to turn this number of children to 1. What do I mean by that? I'm going to show you. So we're going to take 6 and divide by itself, divide by 6 to turn this into a 1. That's the first thing I want you to do. So that's step 3. Divide by first target number, I suppose, if you want to call it that. Or maybe the target's first number. So this here is a target side, and we're dividing by itself to turn it into a 1. That's what you have to do there. Okay, so divide by the first target number. And then what we're going to do is make the 1 turn into 100. Okay, that's pretty straightforward. That's pretty easy. We know to get a 1 and turn it into 100, you multiply 1 by 100. So whatever this final number is, you're multiplying by that target then. So step 4 is to multiply by the target number, the final target number, I suppose. We're making a list of rules. Now, of course, whatever we've done on the right-hand side, we're now going to do to the left-hand side. So when we take 1 and we divide by 6, the same as what we did over there, by the way, that's how I know we should divide by 6. I'm then going to get my calculator and see what that is. Now, we could potentially just leave it as 1/6 there, but I'm going to go ahead and turn it to a decimal. So 1 divided by 6 equals 0.16. And then I'm going to take that number and times it by 100, the same as what I did on the right-hand side here. So that's 0.6 by 100 is going to give you 16.6. Okay, because I do think there was another decimal there that the calculator wasn't showing. So 16.6 adults or leaders for every 100 children. And technically, you can't have 0.6 of a leader. So you probably need to round up to a whole number there, 17 leaders for 100 children. Okay, because you can't have 0.6 of a leader. There's using a kind of a concrete everyday example of this. And I suppose we probably just to annotate it one little bit further. What am I talking about here? When I say divide by the first target number, that's this one here. So this is the first target number. So we divide that number by itself. And then this here is probably what we would call the second target number or the final target number. Now remember, I'm not showing you any tricks here. I'm showing you a process of using ratios. Now at this point, if you want to pause and take down this as an example of how ratios work, probably a good idea if you want to pause the video, go ahead and take that one down. Okay, so at this point, probably a good step to just go ahead and see, can you apply this to some examples? So say we had, let's just go back to the booklet here for a second. You can go ahead and you can pause the video if you want to recap that and read again. Pause the video and read through this little section from here down to here. Okay, if you want to pause and recap, it's the same kind of idea as what I just did there. Pause the video and do that now. Okay, and then what we're going to do is we're going to take an example here. Maybe we'll try the first one together, and then you guys can do the rest. So it says use the same ratio above of 1 to 6. How many liters are there needed for 40 children? So what I'm going to do is I'm going to do this step by step with you. What's the first step we should do? So pause the video and try and do the first step. Okay, so you should have done the first step now, which is to write down the ratio. 1 is to 6. Label them. This is 1 liter for 6 children. So liters to children, 1 to 6. Okay, next bit. You take over from here. What do I need to do then? Okay, go back to the question actually, just so you can see. 40 children. Go back over here, pause the video, do the next step. So the next step is to write down the target, 40 children. Now it's 40 and it's on the children's side, so I'm putting it down here. 40 is the target. And I don't know what the equivalent amount of liters is. Okay, so next step, see if you can do it. Again, you can look at your notes and follow the steps if you need to. Maybe you can remember how to do this. Okay, so this is what you should have done. Taken the first target number and divided it by itself. Divide by 6 and turn it into a 1 here. Okay, go ahead, do the next step. All right, so you've taken that 1 and you've turned it into a 40. How do you do that? Take 1, turn it into 40, you times it by 40. Apply the same to the other side now to get the final answer. Do that now. Okay, so what you should have done here is taken the 1 and divided it by 6. So we'll go ahead and do that. 1 divided by 6 equals 0.16. Keep that on the calculator. Then go ahead and multiply this by 40, the same as on the other side. Times by 40, and you should have got 6.6 and rounded that to 7 because you can't have 6.6 liters. Okay, now sometimes you could leave it at 6.6 depending on what we're talking about, but you can't have 0.6 of a person, right? So probably round it to 7 people for 40 students and 40 children. All right, so you're ready to have a go at the rest of these in question 16 now. So let's go ahead and see, can we apply that idea? It says 16, A to E. All right, so we're going to go through them answers the next day in class. I just want to show you the next other way of doing it. What if it gives you an amount of liters and asks you how many children can be supervised by them? So it's the same ratio again, 1 liter to 6, and then you've got the liter. So let's go ahead and do one of those examples with you. So again, the first thing you do is write down the ratio 1 to 6. And then it said how many children can be supervised by 8 liters. So this time I'm writing down my target. I'm going to go ahead and label this. This is liters. This is children. So liters to children. And notice that this here is the target is 8 liters. So this time I'm putting 8 on the liter side. I'm trying to figure out how to turn them into children. So follow the next steps. Divide the first target number by itself. Lucky for us, it's already a 1, but it might not always be. So 1 divided by 1 is 1, by the way. So you just divide it by 1, and then you're going to, divide it by 1, and then you're going to go ahead and multiply it by 8. Okay, and on this side, you're going to divide the 6 by 1, and that's going to stay 6, by the way. So this step seems unnecessary, but that's only because this is a 1 in our main ratio. Then you're going to go ahead, multiply by 8, and you should get 48. So 8 liters, 48 children. Okay, that's the ratio. So you're ready to do the next one. So go ahead, pause the video and do part B and C in 17 now. Go ahead, do that. All right, so the next question gives you a different starting ratio, 3 liters for every 11 children. Okay, again, I don't think I need to show you this. You just change the top ratio. I'll show you one. We'll do one. Okay, so it says 3 liters for every 11 children. How many liters are needed for 22 children? All right, so let's try this one together. Okay, so you got 3 liters for every 11 children. So this is step 1, write down your ratio. This is liters to children. Okay, and it says how many liters are needed for 22 children. So first step is to write down your target. My target is to get to 22 children. So on the children's side, I'm writing the number 22. Next step, take your first target number and divide by the first target number. So divide 11 by 11, turn it into a 1. Then you take your 1 and you turn it into 22. I do this by multiplying by 22. And then I do the same on the other side. 11 divide by 11, sorry, 3 divide by 11 gives me 3 divided by 11 equals 0.27. And then I take that and I times it by 22, same as I did on the other side, times by 22. 6 liters for 22 children. Okay. All right, so I think you guys are ready to take that now. And again, if you need to, you can always pause and go back and watch. Take that on do B and C on 18 then. Go ahead, do that. And then we're doing 19 as well. Sorry, gone a bit hey, why don't we do question 19 as well? It says, how many children can be supervised by this many leaders using that ratio, 3 leaders, 11 children. Pause the video, do them now. Now, I just wanted to show you, okay, again, we'll go through the answers to them in the next class. I just wanted to show you an alternative way of doing any of these problems, okay? And that is to use a unit analysis. So just want to show you that it can use ratios or unit analysis for most of these problems. So let's say in this case, C, 80 children. And we're trying to find out how many leaders are needed for 80 children. That's the question. How many leaders are needed for 80 children? So I'm going to go ahead and write down what do I know. I know I've got 80 children. So 80 children. I want to convert to leaders. So I'm going to times by children on the bottom, because I want that to cancel, to leaders. So this is our relationship. It's essentially the same thing as the ratio, children to leaders. Okay, so how many children for how many children per leader? So we know from our question, 3 leaders for every 11 children. So that's what I put here, 3 leaders, 11 children. So now children will cancel out and leave me with leaders. And I've got a sum to do, 80 times 3 over 11. We'll go ahead and do that. 80 times 3 over 11 equals to 21.81 liters. And of course, you're going to have to round that to 22 because you can't have 0.81 of a liter. But that should be the same answer you got when you use the ratio. So I just want to show you how those two things link together and essentially are the same thing. Using a ratio or using a unit analysis where you use a fraction is essentially the same thing, because a ratio and a fraction are basically the same thing written in a different format. So I just wanted to show you and make those ideas and those links clear for you. And to be honest with you, when you're doing these problems, you can do it either way. Sometimes it's better to use a ratio. Sometimes it's better to use a unit analysis, but both are very useful in different terms. And it doesn't really matter which you decide to use, so long as it does work for the problem that you're working on. All right, guys, that's a little bit of maths and chemistry, but also fundamental basic maths, fractions and ratios, really, really important things everywhere in life. So that's it, guys. I'll see you in the next video, and I will correct these in class the next day.